Type 3 is the third type of logarithm or exponential equation that we're solving. This one specifically says we're going to use a common base. So to use a common base, well, you're going to use a common base to solve your exponential equation. Okay, notice here how it says you're solving an exponential equation. Do we have any restrictions on exponential functions for your domain? Do we have any restrictions here? No, your domain is from negative infinity to positive. If you look back at your notes that we did for exponential functions when we were graphing them, there were no restrictions on your domain. That also represents another thing. Notice how in the last couple pages we've seen to check for extraneous solutions, we don't have that here. So since we're solving an exponential equation, we do not need to check for extraneous solutions. You're welcome. All right, let's look at question 11. So for question 11, in order to solve this, you need to have a common base. That means that both of these big numbers, the 5 and the 25, need to be the same. Both of them aren't the same right now. How could I make both of these the same? 5 is already 5. Is there a way for me to rewrite 25 with the base of 5? This is what I mean. You have 5n plus 10, and that's going to equal 5 to some exponent. What exponent can I use that will equal 25? 2. If you plug in 5 squared, that's going to give you 25. Notice how both of your bases are the same? That's what you're going to do for all of these questions. Anytime it asks you to use a common base, you want to get both of these bases to be the same. The most common bases you're going to see are 1, 2, 3, 5, sometimes 4, but those are the main ones. 1, 2, 3, and 5, usually. So that's what I would probably start with. Okay, so once you have this, we need to think. We did this when we were solving on the first type. Whenever we were doing the inverse of log is exponential, right? That's vice versa. The inverse of an exponential function, like we're going to see here, is a logarithm. So some teachers will just say, oh, just cancel out the 5s. No, what I want you guys to do is rewrite this as log base 5 of 5. Really quick, what does log base 5 of 5 equal? 1. It's from your little reference chart right here. Log base 5 of 5, so any base, any number, as long as they're the exact same, will equal 1. So that's why I'm saying it will cancel. So log base 5 of 5 is gone. We're going to move that n plus 10 to the big part. Make it a part of your actual problem. So it's kind of using the power property to move down. Same thing here. Log base 5 of 5 in blue, that's going to cancel. That's going to move the 2 and now make it a regular big number, no longer an exponent. Guys, once you have that, you're just solving. So I'm just going to subtract 10 on each side, and n will equal negative 8. Elias, do I need to check this? No, I don't. Since there's no logarithm, since it's just exponential, we're just going to leave this as our answer. All right, I'll help you start off the next one, but you guys are going to try to attempt number 13 by yourself. All right, for the next one, 12. Okay, Elias, let's just talk about it. We have 9. 9 is smaller. Is there a way for me to rewrite 9? Don't write this out, guys. Is there a way for me to rewrite 9 to some exponent and make it equal 27? No, I mean, at least if there is, it's probably going to be a fraction. I don't want fractions. Okay, so we're going to need to find a different base for both of these. Elias, what base can I use? We already gave you the common ones. 1, which really isn't going to help because it's not going to change. It'll constantly be 1. 2, 3, and 5. Those are the main ones. 3. Okay, let's rewrite both of these with the base of 3. Now you have to tell me, 3 to what power will give you 9? Elias, don't make this difficult. With 3 to what power will give you 9? No. 3 to what power will give you 9? 2. So this will just be a squared. A plus 2 will be still in my numerator, so leave that there, put it in a parentheses. Elias, try 27. 3 to what power will give you 27? 3. Perfect. Both of our exponents are now the same. Before I do anything else, before I do the log on each side, guys, do this next part. Distribute the 2, that's a 4 at the end. Distribute that 2 for the first number, and distribute your 3 for the second one in your exponent. I don't want you to lose any of those values, so that's why I'm having you distribute now. Once you have that, we need to do the inverse of exponential, which is log. So I'm going to take the log base 3 on this side, and log base 3 on this one. Whatever your base is, the common base, you're just going to make that your log base as well. This cancels, this cancels. So you're going to solve the equation. 2a plus 4 will equal 12a minus 6. Solve it. Remember, once you solve, you don't have to check, but I do want you to move on to question 13. Start that one off. So for question 12, remember, you don't have to check. Your answer should just be 1. All right, last question we're going to look at is question 13. Okay, so for question 13, we have 8 over 64 to the negative 3n power, and then we have 32 to the 2n power. Mia, what base can we probably get this to be? All three of them, the 8, the 64, and the 32. We need them both to have the same base. You're saying a 2? 2 to what power will give you 8? 3. 2 to what power will give you 64? 6. And then it's going to equal 2 to what power will give you 32? 5. Good. Awesome job. So guys, before we finish this up, let me again simplify my numerator, or my exponent. 2 to the 3rd power over 2 to the negative 18n will equal 2 to the 10n power. My concern and question is, because I know you guys will mess up on this, how do I simplify the stuff here to the left? Say it again. Well, how could I do that? Lorraine, say it again. Subtract what? 3 and negative 18n. This is just regular, like, don't write this out. This is the same as x to the 3rd power over x to the 5th power. All you would do here is you would just subtract the exponents. You're doing the exact same thing, you just now have something else to consider. So I'm going to do exactly what Lorraine said, and we're going to subtract. We're going to make this 2 to the 3 minus negative 18n. Be careful with your sign. Right, and the other side will equal 2 to the 10n power. This is what I want you to finish solving. From here, it's just basic solving. So we're just going to make this 2 to the 3 plus 18n power and make that equal to 2 to the 10n power. And then from there, we're of course going to need to take our log on each side. This will be log base 2, since my base here is 2 and my base here is 2. Log base 2. And that's going to move each of our exponents to the front by the power rule, or power property. So we can make this 3 plus 18n will equal 10n. And then from here, guys, it's just solving. So I'm going to subtract 3. Actually, let me subtract 18 on each side. That would be smarter. Subtract 18n, 18n. So this will give me 3, which equals to negative 8n, and then I'll divide both sides by negative 8. So n will equal negative 3 over 8. That would be your answer. And since this does not require us to check for any extraneous solutions, this would be our solution. That would be it. So for the questions that we just did, we did all 3 of them, but your homework tonight will definitely go through a few more. So make sure you actually take the time to learn this concept.